Welcome to this new session on food effect analysis. So basically we'll be doing here a non-compartmental analysis to understand the effect of food on the pharmacokinetics of the given drug. So here is a ATPC dataset, an example data again, and I have performed some basic data transformations over here. Let me quickly show that to you, each step. So over here, what I do was there were a few um, missing values in the date time column. So basically here you can see how um, the subjects are divided into different periods and different sequences wherein fasted and fed status were checked. And here the first thing I did was look at each column and see if there are any missing values, and the ARFT-DTM column had missing values, the date time column basically. So I removed those NA values in the column, and then the PC-DTC column over here. Let me quickly show that to you. Yeah, over here I converted this to a date time column. So when you use the date time function, it adds a T character between the date and time, making it readable for this by the application. And I converted the ARF to DTM also using the datetime function, calculated the actual time by subtracting PCDTC from ARF to DTM, and also created a BLQ indicator column. So which value is BLQ and which is not. So one is, if I say 1, the value would be, the concentration will be BLQ, else it is not. So that is an indicator column. The route I defined, and then I also calculated, try to create a new column for nominal time, um, and sorry, this is not nominal time but the actual time calculation itself, and also I converted the eval column to a number. Previously it had text as well, and also dose column. So over here, the dose column, yeah, over here. So I just took, so this just had both um, uh, number and text with this, so 100 milligrams, something like that. So I just kept the first part of the data or the column. So using the split function, you can try it out and convert the dose column to a number. And now I started creating the nominal time. So in the ATPT column over here, ATPT, yeah. So we have both text and numbers that defines the nominal time, right? So we would just need the numbers that are just before the text. So I did some basic transformations here. You can try it out each step. How would I come up with the nominal time calculation over here, and also this whole data set had multiple analysis. So I just separated part C, that is the food effect data. So over here we can see that each subject underwent both um, fed status and fasted status, looking at wherein plasma concentrations were collected to see if there was any effect of food. So let's, after this data wrangling, so I forgot to say one more thing, that is this data had both, let me bring to that column, yeah. So this data set had both parent and metabolite. So basically this is our parent and this is our metabolite. So we had concentrations of both the analyte over here. So let's this filter only for parent for now. I can do that by transforming the derived data rather than just making the changes in the previous one itself. I will click on transform. So now you see the derived data set becomes my source data here. So I will just filter, say, my param CD column. If it is PAI XXX, that is my parent, should be filtered, should be included. So now it is just includes, yep, over here. So we have only the parent, and now it's ready. So let me just rename it to parent food effect. So this is just to try out. I'm just filtering it for parent. You can do it for both the analytes. So click on done. Now I have the dataset ready for analysis. Let's move forward and perform food effect analysis. Click on run a new task over here and say this is NCA for food effect and click on next. So now we'll choose the parent food effect, the one that we wrangled in the last. So click on that dataset and click on next. So now we need to choose the columns. So here my actual time was ATPT new. So I would choose the column here, and my observations are coming from the eval column. Choose the eval, and the nominal time was coming from norm time, right? So that we'll choose that over here, and let's group subjects based on the sequence and period. So basically my sequence here is TRT sequence actual. So I'll choose my sequence column. So some subjects fasted and fed was the sequence, some was fed and fasted. The same way, let's choose the period column as well. So APHC is my period column. So I have both now, sequence and period that has been grouped. Subjects have been grouped. So I have 8 subjects in first sequence and 8 subjects in the second sequence as well. So now the data set, you see that all the 7 steps have been unblocked and you're good to go directly to look at the summary observation versus time. So here we can clearly see how the profiles do look like in each of these sequences. I can just uncheck the split interfaces to see a clear view of how my data looks like. Yeah. So this is just an exploratory step to look at the data closely. And once you're done, you can click on the step 7 directly. I'm highlighting more into deriving the results and getting into the actual output that we need. The other steps are also important. You can go through how to perform the how to set NCA preferences, how to explore subjects in other videos previously that I've shown. So now you see that we have got our parameter summary table, our parameter summarized for each of these sequences and periods. So now we would generally food effect analysis, the output, we would need the geometric mean in each of these. So let's create that kind of a table now. Add parameter table. You can use this version as, or else I'll show an easier one. So now we have the derived data set, right? So we have derived all our parameters. Let's click on the raw result over here, click on preview, and here you will observe that we have the parameter summarized, or the result for each subject written given in separate columns. So let me download this as a CSV. Click on confirm. So this gets downloaded over here. Let me complete this task over here. Yep. Now my task is complete. Let me upload that dataset that I just downloaded. That is my raw result file. So this was the dataset that I was showing, right? See each subject, what is the Cmax, Tmax, AUC in each row, in each of the sequence and period. I click on done, and now we just need to perform one single step before we just move forward. So that is making the raw result file readable for getting us the geometric mean ratios. So to do that, I click on transform dataset over here, The sequence column that you see over here, it contains fasted and fed, but it does not kind of reflect which is our reference and test, right? So in PumasCP especially, you would need to specify which is your reference and test here during data wrangling itself. You don't have to do later in that during the analysis. So we can do that by creating a new column and say if TRT sequence actual is if it is fasted um, within double quotes fasted fed, then the value should be reference test or RT, or it should be test and reference or TR. Now I can call this as sequence, and now you see that a new column is now created for sequence. So this column is readable easily by PumasCP, and you don't have to bother mentioning which is reference and test later during the analysis. The same way we will quickly do it for period as well. Let's use the split function um, to say in the period column we have the numbers at the end of the text, right? So let's just take the second part of the value. So I would say split a period C column the second value, and I'll call this as period. There's something that I'm missing over here. So I guess I've used a curly brackets. So split a period C, and yeah, small things. No. So this will give me my period column over here. Both sequence and period is now ready to go for, we can go for analysis. I can have this as a string, or I can convert this to a number as well. So I'll just convert for uh, demonstration sake. So I'll convert the period to number or integer for now. Yeah. So this is now ready. I'll click on done. And now you can click on run a new task. So here let's give this a name, food effect analysis, and click on next. So here is the main thing that I want to highlight. So um, we use the non-compartmental analysis module to derive the PK parameters, right? So now we are using the bioequivalence module to get the output, the geometric mean ratios for this particular study design. Because it's a crossover study, we would need to understand the design as well and get the results, right? So I'm using the bioequivalence module to get my output. So I'll click on next and choose my data set as the one that I just derived, NCAFE. I'll click on next. So my ID sequence period columns have been mapped. I click on next. I'll directly go to set B preferences. So now you see that just by mentioning my sequence and column in my dataset, the application automatically recognizes the design, the sequences, the periods, and also the number of subjects in each of these sequences. So, you can avoid any confusion later during the analysis. You can also choose which parameters you want to be tested during the food effect analysis. I'll just make it I'll just choose Cmax, AUC last, and AUC infinity observed for now. I'll go and click on next step. So now you see it has created tables. So for a non-replicated crossover design, I'm getting my T by R ratios and confidence intervals around it. Same thing for AUC last and the AUC infinity observed. So you can use the bioequivalence module like this because this is a complicated design. We have a crossover study. It is not straightforward. So if it is a parallel study, it is a different way. I'll show that in the further coming videos. But this is an easier way to get your results for food effect analysis. This way, you can analyze your PK data in your food effect analysis in PumasCP. If you have any questions, you can post it or email us at support@pumas.ai. We'll help you resolve any issues present. And thank you for watching this video. Hope this helps. Thank you so much.